In this video, we want to look at solving the equation cos of x equals negative 1/2 for x, where x is between 0 degrees and 360 degrees. So the first thing we want to do here is we want to think about where is cos of x equal to negative 1/2, and we're going to look at that on a unit circle. So on a unit circle, we know that cos is read off the x-axis, and we know there's a little bit of a pattern going on here with the exact values of sine and cos, and that it goes negative root 1 on 2, negative root 2 on 2, negative root 3 on 2 as we go in that direction. So it's this one here that we're interested in. So we want to be at this position on the unit circle, or we could even be up here at this position on the unit circle. And to get there, we actually need the biggest angle away from the horizontal. So that means we're talking about the 60-degree angle, and if we just draw these lines in here, we want to be 60 degrees back from the horizontal, or we want to be forwards 60 degrees from the horizontal. And that horizontal is 180 degrees measured from the positive x-axis to there. So we can now think about these values. We want 180 degrees subtract 60, and we want 180 degrees plus 60 to give us our two solutions. So that would be from the positive x-axis, this angle here, and the angle around to this point. So summarizing what we've found there, we want x to equal 180 subtract 60. So that would give x is equal to 120 degrees. Or we want x is 180 plus 60, which would give 240 degrees. So these are the two solutions, because we're only going between 0 and 360 degrees, which means that's one full revolution of the unit circle. So they are the two solutions to this problem. So what we're going to do now is think about how these solutions relate to a graph. So what we're going to start with is a graph of cos of x. So this is our graph of cos of x, and we've done it between 0 and 360 because that's the domain that's given in the question. And now this line that I'm about to draw on is going to be y equals negative 1/2. So it's going to cut through the function somewhere here, and its equation is y equals negative 1 divided by 2. And we can see on the graph that there's 2 points of intersection. So there's a point of intersection just here, and there's a second point of intersection over on this side. And the x values there that we've found, this x value relates to 120 degrees, so that's 120 degrees. And the x value over here is going to be 240 degrees. So that's how the solution to cos of x equals negative 1/2 relates to a graph. We start with our first graph, which was y equals cos of x, along with the graph of y equals negative 1/2, which is what we were solving it equal to. And the 2 points of intersection here and here at 120 and 240 are the solutions to the equation that we solved. So if you want to hang around for a few more seconds, we'll just have a look at how to solve that on a calculator as well. So on the CAS calculator, we're going to go into the main menu. And next we're going to bring up the keyboard so that we can type in this equation. So hitting the keyboard button, we can find cos of x. We're going to let that equal negative the fraction 1 over 2. And we're actually going to give it a domain because we know that there's a restriction on this. So the restriction for x, which is what we're calling the domain, is between 0 and 360. So under Math 3, if we click on that, we can now use this given or straight up and down line and type in 0 is less than or equal to x is less than or equal to 360. And it's worth just double checking that your calculator is in degrees, which is at the bottom of the screen there. So now that we have that entered, we just go highlight, interactive, equation inequality, solve, and we want to solve this for x. So we can just hit OK, and that will give us our two solutions. X is 120 or x is 240, which is what we found by hand anyway. So I hope this has helped you when you're looking at solving trigonometric equations or equations involving circular functions. Stay tuned, there's going to be plenty more examples of questions like this, and good luck with any questions you're attempting.